So let's try this again. This is a bit embarrassing to admit, but I did this example wrong, and it looks like I've done it wrong multiple times. So let's get it correct this time. This is now for practice 21.6 in the newer book. So this is a uranium-lead dating problem, and these are kind of confusing. Here's a rock that contains a lead to uranium mass ratio of 0.145 to 1. Assuming that the rock did not contain any lead-206 at the time of its formation, determine its age. What we need to determine here is the ratio of uranium-238 present now to that present originally. And we cannot just use the 0.145 to 1. So what this ratio is telling me, it's a mass ratio, and so we can pretend that it's this 0.145 grams of lead-206 to 1 gram of the uranium-238. Now, of course, it might not be actually that much, but the ratio is the same. This is the amount of uranium present now. So that's NT. We need to find out what N0 is. So N0, the amount of uranium when the rock was formed, is going to be equal to NT plus the amount that decayed. So we know that 0.145 grams of lead-206 has been formed. That lead came from uranium that decayed. But the mass of lead is not the same as the mass of uranium, and so we need to do a little conversion there. 0.145 grams of lead, and there's going to be 238 grams of uranium for every 206 grams of lead. So we can calculate 0.145 times 238 divided by 206. 0.1675 grams of uranium decayed. So that tells me that originally the uranium was the 1 gram that I have left plus the 0.1675 grams that turned into lead. And so N0 is 1.1675 grams. We need the half-life of uranium so we can calculate the rate constant. That's 4.5 times 10 to the 9 years. And so the rate constant is equal to 0.693 divided by T1/2, 4.5 times 10 to the 9 years. So we end up with the rate constant being 1.54 times 10 to the minus 10 per year. And now we can use the equation natural log of NT over N0 is equal to negative KT. So if we're trying to find T, we just need to divide by negative K, and that's the age. So T will equal the natural log of 1 over 1.1675 divided by negative 1.54 times 10 to the minus 10 per year. So natural log of 1 divided by 1.1675 divided by negative 1.54 EE minus 10. And we get 1.01 times 10 to the minus, 10 to the plus 9 years. And that's the way you're supposed to do it. What's really freaky is that when I did it the wrong way, I came out with 1.2 times 10 to the 9, which is actually pretty close. But it happens to work with this problem and not with most problems. So again, my apologies for steering you wrong.